dot or scalar product of vectors. So given two vectors, say vector A and vector B, and these two vectors are co-initial vectors, meaning that they share the same origin. Let's call that origin O. If these two vectors are inclined or have an angle theta between them, we can define the dot product of vector A and B as A dot B is equal to the length or modulus of vector A times the length or modulus of vector B times the cosine of the angle between vector A and B. So A dot B is defined as the length of vector A times the length of vector B times the cosine of the angle between vector A and vector B. Now this product, length of A times length of B times cosine of theta, gives you a scalar or a number. So this is a scalar, meaning that A is a vector, B is also a vector. But when you now perform the scalar the dot product of A and B, which is also called the inner product of A and B, which is given by this formula, when you do this, what you will get is not a vector but a scalar. Hence the second name, scalar product. So scalar here simply comes from the fact that you start with two vectors and multiply, and at the end of the day you end up with something that is not a vector but what? A scalar. Now from this definition we can make one or two remarks. So remarks. The first one is this. Now let's imagine for a second that the angle theta is 90 degrees. In that case, this diagram would look like this. So vector A will be like this, and this vector B. So vector A and vector B. Now the angle between vector A and B is how many degrees? 90 degrees. So what would that mean? So that would mean that vector A is perpendicular to vector B. Yep. So if the angle between vector A and B is 90 degrees, that would mean that vector A is perpendicular to vector B. Or in other words, vector A and B are perpendicular vectors. So that's the first we observe, that when the angle between them is 90 degrees, then vectors A and B are perpendicular vectors. So in that case, what will be the dot product? So the dot product, which is A dot B, would be the length of A times the length of B times the cosine of what? Of 90 degrees. Now the cosine of 90 degrees is 0. Therefore, A dot B will now be the length of A times the length of B times 0. And what would that be? That would be nothing but 0. So what do we get here? We get here that 1. If the angle between vectors A and B is 90 degrees, which implies that vectors A and vectors B, that vectors A and B are perpendicular vectors. It further implies that when that happens, that the dot product of vector A and B will be 0. In other words, whenever the dot product of vector A and B is 0, it will imply that vector A and B are perpendicular vectors. So sometimes you are required to prove or to check or to show that two vectors are perpendicular vectors. So what are you supposed to show? You can show two things. One, you can show that the angle between the two vectors is 90 degrees, or you show that the dot product of the two vectors is just 0. The second remark I want to make from this definition of dot product is that it is possible to know what to find the angle, to calculate the angle between two vectors using this formula. So if we rearrange this formula here, the dot product formula, you see that the cosine of the angle theta is nothing but what? A dot B, that will be the dot product of A and B divided by what? The length of vector A times that of vector B. So that is cosine of theta. So that theta, the angle, becomes the arc cos or the cos inverse of A dot B over the length of A times the length of B. So what are we saying here? That from this formula of dot product, A dot B equal to the length of A times the length of B times the cosine of the angle between them, we can use this formula to find or to calculate the angle between two vectors, and that will be this. So if we're working on this, we have that the angle between the two vectors theta is equal to the arc cos or cos inverse of the dot product of vector A and B divided by the product of the length of vector A times and the length of vector B. Okay. Now I'd like to point this out. Now one thing we should note here about this definition of dot product, because very soon I shall present another definition of another version of this definition, is that to use this definition, let me just call this definition 1. Let's call it 1. To use definition 1 of dot product, you need how many things? You need 3 things. 1, you need to know the length of vector A, which can be known once vector A is known. 2, you need to know the length of vector B, which can also be known once vector B is given. And of course, 3, you need to know the angle between vectors A and vectors B. Very good. So we can take an example now to illustrate. Example 1. We are given the vector A, 2i plus j minus k, vector B, 3i plus 2j plus k. And we are given theta, the angle between vectors A and B, to be 40 degrees. And we want to find the dot product or the scalar product of A and B. So we know already from the formula that the dot product of A and B is equal to the length of vector A times the length of vector B times the cosine of the angle between vectors A and B. So how do you get the length of vector A? You know already from previous videos. The length of vector A, which is the modulus, is what? The square root of the square of the component, of the sum of the squares of the component. So vectors A, we have the components 2, 1 and minus 1. So the square root of 2 squared plus the y component is 1 plus 1 squared. The z component is minus 1 squared. So that gives us the square root of 2 squared is 4 plus 1 plus 1, 4 plus 1, 5, that is the square root of 6. So the length of vector A is root 6. You can write it as decimal, no problem. So the length of vector B now, the modulus of vector B or the length of vector B is the square root of 3 squared plus 2 squared plus 1 squared. That gives us the square root of 3 squared is 9 plus 4 plus 1. That is the square root of 9 plus 4, 13 plus 1, 14. Square root of 14. Okay, we are ready. So the dot product A dot B gives us length of vector A is root 16, the square root of 6 rather, times the length of vector B, square root of 14, times the cosine of the angle between them, times the cosine, and what's the angle between them? 40 degrees. 40 degrees. So we now punch this out, root 6. Root 6 times root 14 times root 40. That should give us approximately 7.02. So the dot product of vector A and B, where vector A is 2i plus j minus k, vector B 3i plus 2j plus k, and the angle between them, theta, is 40 degrees, is 7.02. Approximately the nearest whole number, if you like, is 7. Just 7. So what do you see here? A and B are vectors, but the dot product is what? A scalar. Hence the name, scalar product of vectors. Okay, we shall take another example now. Okay, here we have vector A, 2i plus j minus k, vector B, same vectors as we had in the previous example. But now, what are we asked to do? We're asked to find the angle between vectors A and B. Okay, so remember the angle between vectors A and B here was 40 degrees, right? So here we want to see if we can actually get that angle as 40 degrees. So how do we go about this? You recall that from our definition of dot product, which is A dot B equals to the length of A times the length of B times the cosine of angle theta. We had deduced from here that the angle theta between vectors A and B can be obtained using this formula. So theta, the angle between vectors A and B, is the same, can be gotten as the cos inverse or the arc cos of the dot product of vectors A and B divided by the length of vector A times the length of vector B. So theta is equal to the cos inverse of, now A dot B means the dot product of vector A and B, which had already been calculated in the previous example. So A dot B, we had 7.02, which we wrote as 7. Let's just use 7.02 to avoid too much approximations. So 7.02 divided by the length of vector A. Length of vector A is here, square root of 6, times the length of vector B, which is what? The square root of 14. Okay. Now, so this gives us that this is a cos inverse of 0.765944, goes on and on. So if you divide 7.02 over root 6 times root 14, you get this bunch of numbers. So when you look at the cos inverse of this bunch, so theta, therefore theta is equal to, that will give approximately 40 degrees. So you should try to confirm this. So what do you see? You see that with the formula of the dot product, which we tweaked to this, we have been able to find the angle between what? Vectors A and B. And that corresponds to what we had here as 40 degrees. So in the example number 1, we were given two vectors A and B, and we're given the angle between them as 40 degrees. And we're asked to find the dot product of A and B, which we did and got approximately 7. In the second example, we are given the same two vectors, but this time we are asked to find the angle between the two vectors. And we have also seen here that the angle between the two vectors corresponds to 40 degrees. Okay, now the next one to look at is the alternative definition of this dot product. Before then, just to remind you, you observe again, let me emphasize, in this definition of dot product, this definition cannot be applied unless we know the angle theta between vectors A and B. Of course, once vector A is known, the length will be known, and once vector B is known, the length also will be known. But we are not given the angle between vectors A and B at all times. So this second definition of the dot product will take care of the fact that the angle between the two vectors is not known. So definition 2. If we are given two vectors, vector A, the component A1, say A1i, plus A2j, plus say A3k, and vector B is given as A2i, plus, or let's use B now, B1i, plus B2j, plus B3k. We can define the dot product of vector A and B, so we can define A dot B as, what we'll now do is, on vector A, the x component is A1, and on vector B, the corresponding x component is B1. So we shall multiply A1 and B1. So that becomes A1, B1. So A1 times B1, A1, B1, plus the y component of A is A2, and the y component of B is B2. We now multiply A2 and B2, A2 and B2, plus the z component of vector A is A3, and the z component of vector B is B3. We now multiply A3 and B3. Of course, we can go through the proof of this formula, but I don't want to make the video that long. So A dot B can be given as A1B1 plus A2B2 plus A3B3. So what do you see here? This is just a product of the corresponding component of the x on the corresponding x component, and this is the product of the corresponding y component, and this is the product of the corresponding z component. So once you do this, you can also get a dot product. But what we observe here is that this formula can be applied even when the angle between the two vectors is not known. So in the previous example, you observe that we were given the angle between the two vectors. But here, to use this formula, we do not necessarily have to know the angle between the two vectors. So just to clarify us, very well, I'm going to solve the same example, as in the previous case, but this time without the angle. So we are asked to calculate the dot product of vectors A and B, given that vector A is 2i plus j minus k, and vector B is 3i plus 2j plus k. Now, these are the same vectors we had in example number 1. But in example number 1, we were given the angle between them as 40 degrees, which enabled us to use this first definition to find the dot product. And the second example, we are only given the two vectors A and B without the angle between them. So can we still find the dot product? The answer is yes. So we can go now to definition number 2. So we know already, so solution. The dot product A dot B can be gotten using the components. Now the x component for vector A is 2 and the x component of vector B is 3. So I'm going to now write 2 times 3 plus the y component of vector A is 1, but this is j, so this is 1j, and the y component of vector B is 2, so I just multiply 1 and 2, plus the z component of vector A is negative 1, this is minus k, so that is minus 1k, and the z component of vector B is 1k, so that is 1, so I just multiply negative 1 and 1, so that gives us 2 times 3 is 6, plus 1 times 2 is 2, minus 1 times 1 is negative 1, so that is minus 1. And what would that be? 6 plus 2 is 8, 8 minus 1 is 7. And that corresponds with what we got when we used A and B alongside the angle between vectors A and B. So you see that this method can be relatively cheaper and faster, of course. So with this method number 2, we do not need to know the angle between vectors A and B, and of course this is a method that is often used to find the dot product of vectors. But you should be able to understand the difference between the two definitions. All right. We shall now take one last example. Example says we will find the value of beta for which the vectors vector A is 6i minus j plus 3k, and vector B is 4i plus beta j minus 2k are perpendicular. Now what we observe here is that the component of vector B, this y component, is not known, but it is 4i plus beta j, so beta here is an unknown. Okay, so we're asked to find the value of this beta. But what we have to take note here is that we are told that these two vectors A and B are perpendicular vectors. So what does it mean? What does it mean to us when we are told that vectors A and B are perpendicular vectors? So let's go back to our very first slide. Now recall that when we define dot product of vectors A dot B, in the first remark we said that if the angle theta between vectors A and B is 90 degrees, it will imply that vectors A and vector B are perpendicular vectors. And that also implied that if the angle between vectors A and B is 90 degrees, it straight implies that the dot product of A and B is 0, since cos 90 degrees is 0. In other words, if vector A and B are indeed perpendicular, two things happen. Number one, the angle between vectors A and B should be 90 degrees. And number two, the dot product of vector A and B should be 0. So we're asked to find the value of beta that makes these two vectors perpendicular. So, solution. Now, vectors A and B, A and B are perpendicular, just write as PEP, if A dot B is equal to 0. That's what we know. If A dot B equals to 0. Of course, there's another thing we know is that if the angle between them is 90 degrees, I beg your pardon. But this is what we want to use. Of course, to get the angle between them, vector B must be completely specified. Is it not so? Because we must know what beta is. So without knowing what beta is, it will be difficult using it will be difficult getting the angle between them. Okay, so we'll go with this. So if the dot product between vector A and B is 0, this tells us straight up that vectors A and vector B are perpendicular vectors. And we are told in the question that these vectors are perpendicular vectors. Alright, so A dot B simply means vector A is 6i minus j plus 3k. We want the dot product of that vector with this other vector. Vector B is 4i plus beta j, the component we are looking for, minus 2k. And what do we know? We know that this dot product is 0. Why is it equal to 0? It's equal to 0 because we are told that vectors A and B are perpendicular vectors. So from here, we can just apply our definition 2 of dot product to find the dot product of vectors A and B. So this is equal to, so the x component of vector A is 6 and that of vector b is 4. So we'll just multiply 6 and 4 plus the y component of vector a is -1 and the y component of vector b is beta. So that is -1 times beta, which we do not know, plus the z component of vector a is 3 and that of vector b is -2. So 3 times -2. And what do we know? The dot product is equal to what? 0. So 6 times 4 is nothing but 24. So -1 times beta is negative what? Beta. 3 times -2 is negative what? 6. And that is equal to 0. From here we can now solve for b. So 24 minus 6 is 18 minus beta equal to 0. Therefore, beta is equal to 18. What are we saying? So we have found the value of beta that makes a and b perpendicular vectors. So we are saying in essence that if vector b now is written as vector b is equal to 4i plus what is beta? Beta is now 18 plus 18j minus 2k. Now this vector b is 4i plus 18j minus 2k. Then the dot product of vector a and vector b will be 0. In other words, vector a and vector b will be perpendicular. Let us check if that is true. So vector a is 6i minus j plus 3k. So dot product of that vector with our vector b, which is now 4i, we are claiming our beta is 18, 4i plus 18j minus 2k. So let us see what happens to the dot product. So dot product gives us, so this is 4, let me just do it gradually, 4 and 6 times 4 plus the y component is -1 and 18, -1 and 18, and the z component is 3 and -2, 3 and -2. So 6 times 4 is 24, -1 times 18 is -18, 3 times -2 is -6. So 24 minus 18 is 6, 6 minus 6 is 0. So indeed we have confirmed that if beta is 18, then vectors a and b shall be perpendicular vectors. Very good. I hope you do understand. So since we now know what b is, we can now probably find the angle between vectors a and vector b. And if you find the angle between vectors a and b here, you'll observe that that angle will be nothing but what? Theta will be what? 90 degrees. So I leave that to you as an exercise. So you can try it out using our formula, cos inverse of what? A dot b divided by what? Divided by the length of vector a, length of vector b. Of course, that's even obvious because a dot b is already 0. You know, so the cos inverse of 0 is 90 degrees. And in fact, that is the answer. I hope you do understand this lesson. Please do drop a like and a comment on this video, and please subscribe to my channel if not done so already. Thank you and bye bye for now.